We're made of star stuff. We are a way for the cosmos to know itself.
We're made of star stuff. This term was coined by the astronomer Carl Sagan 50 years ago, and it's since made it into pop culture. But what does that even mean? And is it true? Let's see what the universe has to say about this. Welcome to Chasing Starlight. I am Susanna Randall, an astronomer at the European Southern Observatory ESO, and apparently I am made of star stuff. And so are you. Take a look at your body. You can see that you're made up of skin, bones, muscle. If you zoom in with a microscope, you'll find that we're made up of cells. And if you go even deeper, zoom in even further, you'll see that at the atomic level, we're made up mostly of 6 elements: hydrogen, oxygen, carbon, nitrogen, calcium, and phosphorus. And to tell you where these elements come from, I have to start at the very beginning, at the Big Bang. In the first few 100,000 years after the Big Bang, the universe was a dense, hot, gooey plasma. And what happened after that is basically it expanded and cooled down. After about 400,000 years, the universe had cooled enough for the first stable atoms to form. And unsurprisingly, these were the simplest atoms. So we had some helium as well as traces of other elements, but mostly the universe was made up of hydrogen, the simplest of all elements, consisting of just 1 proton and 1 electron. So that means my body is made up to 10% of something that comes from the Big Bang. And that makes me a lot older than I care to think about. But you can't make up something as complex as the human body of just helium and hydrogen. So where do the other more complex elements that make up our body and the rest of the universe come from? The first elements in the universe formed diffuse gas clouds called nebulae, where stars form. In fact, we can still see stars forming in these nebulae today, like in this spectacular image taken by ESO's VISTA telescope. So what happened in the nebula is that there were regions that were a little bit denser than others, and these regions started accreting more and more mass until they started to collapse in on themselves. And in the inside of this core, the temperature, pressure, and density increased more and more and more until the temperature was high enough for hydrogen fusion to start, and a star was born. Our own star, the Sun, was created exactly this way 4.5 billion years ago. And since then, it's been happily fusing away hydrogen to create helium in its core. But it's not really making any of the other more complex atoms that our body is made of. For that to happen, we need to wait just a little longer. When the hydrogen in the core of the star has been used up, things start happening very quickly. The star enters a new phase of its life called the red giant phase. The outer envelope of the star expands and cools, hence it becomes a giant, and the inner part, the core, keeps on contracting until the temperature is high enough for helium to start fusing. And the helium then creates carbon and oxygen. So carbon and oxygen were 2 of the other elements that our body is made up of, and they make up about 84% in mass of our body. So the majority of the atoms in my body are actually created deep inside stars in these incredibly hot stellar furnaces. But wait, that means that the carbon and the oxygen are locked inside the core of the star. How do they get out? Well, as it turns out, even stars don't live forever. When the helium runs out in the core of the star, if the star is not massive enough to fuse heavier elements, then it stops there. And stars with a similar mass to our Sun, so low mass stars, can't make elements that are heavier than carbon and oxygen. Instead, the carbon-oxygen core slowly cools down. It's this very dense end product of a star called a white dwarf. And the outer layers are ejected into space. They form these beautiful arcs, rings, spirals, shells. In other words, star stuff. On the other hand, stars with more than about 8 solar masses continue to fuse elements in their core, and they create heavier and heavier elements, as heavy as iron. But at some point, even they have to die, and they go out with a bang. They explode as supernovae. Fun fact, a supernova occurs roughly every 10 seconds. So that means that by the time I finish this sentence, a supernova will have gone off somewhere in our universe. During the supernova explosion, even heavier elements are created, and these are the really glamorous ones, like gold or platinum. These are hurled out into space by the explosion, giving us sparkly star stuff. Ironically, stars need to age and die to form the remaining building blocks of life. So we have nitrogen, which is important for the synthesis of our DNA, and we have also calcium and phosphorus, which are important for our bones and teeth. As it turns out, Carl Sagan was right. We are literally made up of star stuff. And the story of stars and their lives is also the story of the elements that make up our body. We're all part of this grand cosmic cycle. But before you get too excited, cockroaches are also made up of star stuff. I don't know about you, but I suddenly feel entirely at one with the universe. I really hope that you enjoyed this episode of Chasing Starlight. If you did, please press the subscribe button and also activate the notification bell. That way you'll be notified of any new episodes. If you have any comments, please leave them below. For every episode, we will answer some questions.